Yes. All right, we'll get started. So yesterday, Seb came to me and he said, look, I just realized I gave you a really long introduction in the thing, so please don't read the whole thing. So in order to save time, I will read every third or fourth word. So Seb, code, Commodore 64, 80s, inspiring builders, AWS, cloud, secret, passion, customer curiosity, software architecture, tools, mobile. So basically, Seb, you're an AWS evangelist, right? That's the take-home message. But he's also a super interesting guy, speaks at a lot of conferences, does some podcasts. You should check them out. Although you might have to learn French first to get the most out of them. So that's homework for you. Seb today is presenting, I think, not in French, right?
I can, if you want.
Show of hands? No. All right, please welcome Seb to the stage today. Thank you.
Thank you. That's the best introduction ever. Thank you for that. I'll try to remember that one. So yes, in this talk, I'm going to talk about Swift on the server side because we can. So I'll try to explain why you want to use a Swift on the server side. And most of the talk is about how to deploy your application, your Swift application on the server side. I'll start with a standard web application written with the Vapor web framework and show how you can deploy that on the server side. And then go to Swift functions, function as a service using AWS Lambda. So that's a lot of buzzword, a lot of keyword. I'm going to try to explain that. And I'll start with a brief introduction about AWS Lambda as well. And as you mentioned, yes, I'm Seb. I'm coming from Belgium. I usually speak French, as you might have noticed already, with a slight touch of French accent I have. And yes, you can find me blogging, writing blogs, podcast, YouTube video, and stuff like that. So there is a lot of words and keywords there: server-side, serverless, Swift. I'm not going to explain Swift, but let's break them the other server-side first. You all write iOS application or mobile application in general, and your mobile applications are using a backend. Typically, the type of service you will get from the backend, it's authentication service, sign in, sign up, forgot my password, multi-factor authentication and stuff like that. Your application is going to consume one or multiple API. It might be REST, might be GraphQL, like we talked about yesterday. These are exposing data from a database. You will probably use some kind of object storage these days as well for your image, your video, and things like that. Especially at Instagram, you have some kind of object storage, most probably. And since a couple of years, we have an option to write this backend using the Swift programming language. Come on, you know Swift already, you have your tooling, you have your library, you know how to write unit tests, you have frameworks. So it makes a lot of sense for independent developer or small companies to actually continue to use the same language that you use on the front end on the back end as well. And Swift is pretty good at that. It's efficient, it's strongly typed, so you have some kind of compile time safety. It has a very good threading model. It's easy to use with async await, for example. It's energy efficient as well. If you look at the list of the top 10 most energy efficient language, Swift is in that list, just like most compile language, Go and Rust and C, of course. Much more energy efficient than other interpreted language, such as Python or JavaScript. So it's important also as a developer to make choice regarding energy efficiency of your solution. So Swift is there, and it's a good solution to deploy a server-side application as well. But if you think about deploying a server-side application, for us, application developer, it means having a Linux server or Windows server. I remember when I first created my first iOS app in 2009 something, I had to rent a VPS, a virtual private server, to install that, to install MySQL, to install Python at the time, to install a web framework for Python. Then I was responsible for scaling this thing. If the application ever has success, you need 2, 3, 4, 5 servers. Hopefully it didn't happen to me at that time. I was happy with one server, but I was also responsible for the availability of that server. What if my server dies? I need 2 servers and a load balancer in front of that. So that's a lot of complexity, and Sam is going to talk about back-end development and infrastructure in the talk right after me. But as a front-end developer, I don't want to care about all that. I want just to deploy my code and let maybe someone else manage the complexity of the infrastructure. And this is where serverless is coming from. And this is where serverless fits into this picture. So what is serverless? Of course, it doesn't mean that there is no server. There is no magic. There must be a server somewhere. But the key of serverless is that you are not responsible to manage the server. Someone else is doing it for you. So I don't need to install, I don't need to patch, I don't need to take care of high availability. High availability is designed by the system. I don't need to care about scaling. It can scale from 1 instance to 1,000 instances, depending on how many calls are made to my application. Automatically, I don't need to change the code. The provider is taking care of the scalability for me. And the best part is that I only pay for what is used. So it scales down to 0. If nobody is calling my API, I pay 0. There is an exception for that, of course, it's storage, because we cannot scale down storage to 0. You want us to keep your file, so if you have a database or objects on S3, for example, you pay for the storage per gigabit per month. But the compute capacity can scale from 0 to millions, depending on your needs, on your application needs. So you pay only for what you use. So how to deploy serverless? On AWS, there is a service called Lambda. You will find similar service on other cloud provider. I just happen to have my AWS hat here, so I will show you how to do it with AWS. But you can most probably, I didn't try, do the same with Azure Function or Google Function as well. But AWS Lambda was the first one in this category. Back 9 years ago, we introduced AWS Lambda. So Lambda, it's a service that allows you, developer, to write code and just deploy that code without any knowledge or caring about the underlying infrastructure. You write code in Python, in Java, in TypeScript, in Node, in C#, in Ruby. I have to read the list, in Go. You package your code and the dependencies as a zip file or as a Docker container, and you send that everything to Lambda. Then your code lives there. It's on Lambda. The infrastructure is managed by AWS. You don't have to take care about that. How are you going to invoke a Lambda function? So typically, you put another service in front of Lambda that will invoke, trigger the Lambda function. In my example today, I will use an API gateway, a REST API. So the REST API will be the endpoint for your HTTP calls. This is where your application, your front-end application, will knock on the door. And the REST API gateway will package the HTTP header, the query string, the parameter, everything, and invoke your Lambda function. But API gateway and REST is not the only option. It might be GraphQL API. We talked about that yesterday. It might be a queue, a message arriving in a queue that triggers your Lambda function. It might be a change in a database. You have a cloud database, something changed in a database, and you trigger a Lambda function. It's a bit like triggers in old relational database, but it's the modern way of triggering code. Or when data change, it might be a file that arrives on S3. It might be on schedule as well. You might have Lambda function that triggers every Sunday morning at 2 a.m. to do some kind of cleanup. So you define the trigger, and your code is called by the trigger. What is it to create a simple Lambda function? Typically, when you're learning AWS, you go to the AWS console. You have a nice web, you have a web interface. Some parts are nice, where you can actually interact with AWS. So to create a function, you go to the Lambda part, you click Create Function, you select if you want to start from a template or from scratch. You give a name, that's the hard part. You choose the runtime, is it Python, Java, Node, or something, and you choose the architecture. So you can choose if you run your Lambda function on x64 hardware, Intel, AMD, or on ARM64, which use AWS Graviton, which is a CPU that we designed ourselves based on ARM. And there are multiple reasons to pre-select ARM. One of them is the price, the price performance ratio is much better on ARM than on x64 equivalent family of CPU, so you have better performance for the bugs. The second reason is energy efficiency. The ARM processor consumes less electricity, so it costs less to operate, it's better for the planet, it costs less to cool down the data center when there is a lot of ARM processor in use. And for us, Swift developer, it's the same software architecture, hardware architecture as the one we have on our MacBook Pro. So you don't need to cross-compile for Intel, you can compile on your MacBook Pro for ARM and ship your binary code unmodified to Lambda. That's the third good reason to use ARM. When you have done that, there is a small text editor there at the bottom of the screen where you can write your code for simple Lambda function. Let's zoom a bit. This one is in Python, and that's the only example I will have with Python during this talk. But the architecture is always the same. You have one function, which is the entry point for Lambda. It's called an handler. You give the name that you want. It receives two parameters. One of them is the JSON of the service that invokes the Lambda function. So if it is an API gateway, it will be a JSON with the HTTP header, the query string, the parameter, and stuff like that. And the second one is the runtime context of your code. What is the container? How much time you have to run? What is the memory size? What are the environment variables? So that's the context about the execution. Then you do whatever you want, and you return a JSON or not. Sometimes maybe if you just have a Lambda function that is invoked when a message arrives, maybe you don't need to give any response back. So it really depends on your application. Once your function is deployed, you have tons of monitoring, concurrent execution time, error rates, so you can see how your system behaves. How do you deploy a Lambda function? You can use the console, you can use the AWS command line, create a function, and deploy with the command line. But most of the time, you want to deploy more than just a function. You need to deploy also something that will trigger your function, like an API gateway or a queue, or you want to deploy a database as well. And as developer, I don't want to spend my time in the console doing click, 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 click to deploy everything. That's not repeatable. I cannot repeat the process between my test, dev, and production environment. So I'm using some kind of infrastructure as code. The idea of infrastructure as code is to have a text file that describes my infrastructure, and then a tool will implement that infrastructure in the cloud for me. So I would like to introduce you Sam. Sam, this is the audience. This is Sam. Sam is the serverless application model. It's a tool that allows you to describe your infrastructure as text, a YAML text or a JSON text, and deploy it in the clouds. So you create a template. It might be a bit long like that, but let's zoom on the specific part. You define your resource, the name of my function, the type that says to Sam, hey, this is a Lambda function. The properties, and without surprise, you're going to find the same properties as in the console. So you will have architecture, for example, the path to my zip file, environment variable, and stuff like that. And then in the second part of the code, I define what are the events that is going to, or that are going to trigger my Lambda function. In my case, I want an HTTP API that reacts on HTTP GET on the path /test to trigger my Lambda function. And that's it. I just type sam deploy, it takes that text file and generates the infrastructure for me. Okay? So last word, because I see the question in some of your eyes. Okay, that's great. I convince you to use a Lambda for your next deployment because it's scale, because it's highly available, but how much does it cost? Actually, it doesn't cost a lot. There are two metrics under which you are going to be built. One is the time, the CPU execution time. And it's a price per millisecond and the size of the container, the memory size of the container. We have large container, smaller container. And the second metric is a price per invocation. And so you see the price, I don't know, even, I think there are 7 zeros there, per millisecond of execution in a 1 gigabit container. If you have a 2 gigabit container, it's twice the price. If you have a 500 megabit container, it will be half the price. Easy. And there is a free tier. So every month, you can get 1 million requests for free, and 400,000 seconds of compute time for free as well. So for test and development, Lambda is free, and you start to pay Lambda only if you have real usage. And for the price of a cup of coffee per month, you can get some decent production workload already running on Lambda. Okay, that's it for Lambda. Let's talk about Swift and deployment of Swift application. And I'm going to start with existing web application, because if you write Swift application for the server side, like API, today, most probably you are using a web framework, such as Vapor, for example, and Vapor is the one I'm going to use in this example. So Vapor, it's a web framework that allows to receive HTTP calls, invoke your Swift code, you do your business logic in your Swift code, and you return a response. So how do you deploy Vapor into something like that? To explain how it works, how you can deploy a Vapor app without changing the source code of Vapor, I need to open up the cover a bit and explain how Lambda works. Then you will understand how you can deploy your web application there. So inside the Lambda micro VM, there is a runtime component that we write, which is specific for any programming language, that is going to pull events from Lambda and invoke your code, so called the handler method that I talked about before. So how do we fit with a web application into that? Because the Vapor application will have its own HTTP container. And you cannot expose HTTP directly from the Lambda function. So what are you going to put there in front? And how are you going to bring the existing unmodified Vapor app inside the micro VM of Lambda? That's the first challenge, how to bring the unmodified version of Vapor into Lambda. And the second is what is going to trigger that? How are you going to call that? So I'm going to use a bit of all the other service I talked before. We have something in Lambda called Lambda extension that allows to trap requests and to transform requests before passing them to your code. So we are going to use an API gateway to terminate the HTTP connection or the HTTPS connection that will be the endpoint exposed to your application. I'm going to use a Lambda extension that will receive the invocation from the Lambda runtime and transform that in a regular HTTP that Vapor can understand. And then I'm going to use Docker to package my web application and deploy that web application unmodified inside the Lambda container. And of course, to deploy all that, we are going to use our friend Sam to create all the different parts of the infrastructure. Okay, it sounds complicated like that. And it's not, because if you have an existing Vapor app, the only thing you need to do is to package it as a Docker file. And the Vapor command line generates the Docker file for you. You just need to add one line in the Docker file, to package the Lambda extension. So the thing that will do the magic of capturing the Lambda invocation and calling your Vapor app. Then you need to write a SAM template to actually deploy that, and Sam will deploy and create the infrastructure for you automatically, the API gateway and Lambda. So one line of change in your Docker file, that's all you need to deploy a Vapor application inside a Lambda function. Once you have done that work of writing the template, you can switch to the command line, Sam build and Sam deploy. That will create a container, compile your Vapor application. I accelerate the video a bit there, of course. Compile your application, create a container, and then upload the container to a container repository, and then deploy that repository to a Lambda function. And at the end, it will even give you the address, the endpoint, the URL of the API gateway that it just created. So if I take that address and put that in a browser, I will see the result of invoking my Vapor app. It's a very simple Vapor app that takes all the arguments it received, the HTTP header, the path, and output that as a text file on the screen. So unmodified Vapor application, deploy into Lambda. Why to deploy into Lambda? Because it's serverless. You don't need to manage the server, and because it's scaled down to 0, so if it is not used, you are not paying for it. If you are curious about the Lambda adapter, the Lambda extension that I use, it's an open source project that we published. It's written in Rust. And the good news is that it works with any type of web application. So if you are also writing web application in Python with Flask or TypeScript and Express, for example, you can also package that as a Lambda function. Okay, do I still have everyone with me? I'm happy that this talk is in the morning and not after lunch, because I need your attention. Okay, can we move the needle a bit even more and go natively to Swift and Lambda? So how can you write a Lambda function directly in the Swift programming, in the Swift programming language? Yes, it's possible, but you need to learn about something else called a Lambda custom runtime. So if you remember my slide at the beginning, I told you that by default on Lambda you can write Python, TypeScript, Java, Go, and Swift was not on that list. So a few years ago we introduced custom runtime for Lambda. The way it works is quite easy. On one side you have the AWS Lambda server service. On the right side, you have the micro VM, and you have your handler code written in Swift. So the idea of a custom runtime is that you ship something that can run inside the micro VM. It can be a shell script. It can be actually anything that runs on Linux. I wrote a Lambda extension in shell just for the fun because it's possible. We have some partners that wrote a Lambda extension for PHP. We have a partner that developed Lambda custom runtime for COBOL, so you can write a Lambda function in COBOL today. And what you need to do is to develop an executable or shell script called Bootstrap, and that Bootstrap makes two API calls to the Lambda service itself. So it's using a REST API, an internal REST API, to pull the events from Lambda. Basically, you make an HTTP call to Lambda saying, hey, do you have an event for me to process? And then the call wait for an event to arrive. When an event arrives, you pass it to the handler code. The handler code does the business logic, returns something, and you make a second call to AWS Lambda, post with the result. And the unit of deployment is your code, just like before, plus the Bootstrap together in a zip file, and that's a custom runtime. That's the technology that allows you to write Lambda function in any programming language that works on Linux. So easy. For Swift, you just need to write a Bootstrap application, make two API calls, get for an event, post for the result, and pass that to the rest of your code. How hard can it be? Actually, it's a bit harder than you think to make that at scale, efficiently, for example, using Swift NIO and not blocking calls, for example. It's a bit hard. So someone did that for you already. Thank you, Apple. On the Swift Serverside Git repository, Apple published a Swift AWS Lambda runtime. So what is this runtime? It's the Bootstrap application I told you before, and some abstraction to make it easy for us, Lambda function developer, to write a Lambda function. I'll let you finish to take picture, and then I move to the next slide. So let's see how you can write your first Lambda function with the Swift programming language. First, you need a project. I'm going to use SPM here, and I need to define an executable target of any name. Then I add dependencies. There are two dependencies to add. One of them is the Lambda runtime itself, so it's the Bootstrap, and Apple did a great job as well at modeling in Swift all the different types of events that can trigger your Lambda function. API gateway is one of them, SQS is another one, S3 is another one, DynamoDB. So all these services that may invoke your Lambda function have a specific data structure that they will pass to your Lambda function, and these are all modeled as a Swift struct. So I'm also adding the dependency for that library. So that's the package setup. Now let's go to the code. Writing a Lambda function is super easy. It's an executable, so I have to use the main decorator on the struct. I create a struct, and I implement a simple Lambda function, simple Lambda handler, which is provided by the framework. There are other options to provide more low-level Lambda function, but for most of the needs, this one is simple and easy to use. The protocol defines one function that you need to implement called handle, and without surprise, it takes two arguments, just like in Python and other programming language. The first one is the event that you receive from the service that will trigger Lambda, and the second one is the context. It's an asynchronous method. It might throw, and it has to return something. In my example, the event and the response are for API gateway, but that depends on the trigger of your Lambda function. And then inside that function is your business logic. So you put whatever you want. Here I'm creating an array of HTTP header. I'm logging something on the console to say, hey, it works. That's my favorite way of debugging stuff. HTTP API message receive. I create a HTTP header for the response. Content type is application JSON. And then I convert the event I receive as a string, and I give that back as a result, just like I did in the Vapor application. It's a demo app that like echo everything that has been received on the output. You can test that locally in Xcode. So this is another project with an iOS app and a Lambda function, and the iOS app directly invokes the Lambda function without going through the REST API. If I take the Lambda target, I can configure on the Lambda target an environment variable. I always forgot the name, so you have to read it really quick. It's local Lambda server enabled equal true. And when you execute your Lambda target, the framework provides a mini web server that listens on the port TCP 7000. So if you configure your client app to use the same port, you can actually test your Lambda inside Xcode. And here I'm switching to my iOS target. I switch the console back to the Lambda target to see the output. And I enter a username, a password, click register. That invokes the Lambda function. You can see that the line has been changed on Lambda as well. And from there, you can put a breakpoint, and you're in a familiar environment to actually debug your code. Okay, now you have your Lambda function. It works on your laptop. That's the first step. So how are you going to package and to deploy that? The answer lies in SPM plugins. Swift Package Manager plugin. So what is a plugin? It's a construct from the Swift Package Manager that allows developers to create additional comments that the user of the framework can use to do additional tasks on top of building, testing, and deploying. So inside the Lambda runtime provided by Apple, they added one SPM plugin called archive. So I can type the command Swift package archive, and it will prepare the zip file for me. I will explain the disable sandbox in a minute. So what does it do behind the scene? Again, Lambda runs on Linux, so you need to compile your Swift code for Linux, which you cannot do that directly as is on your Mac. So it uses Docker for that. It takes a Linux image with the Swift runtime installed. It compiles all your project inside that Docker image, and that produces a big binary file on your hard drive. And then it zips that file together with the bootstrap provided by the framework, and you have a zip ready to deploy. The reason why there is the -- disable sandbox on the command line is because plugins are running within a restrictive sandbox, and the sandbox today cannot make network call to the outside. But Docker, the way the Docker command line works, to communicate between the Docker command line and the Docker daemon working on your machine is through local sockets. So to be able to invoke Docker, you need to disable the sandbox until the plugin system will have a more granular permission system that will allow us to define exactly what is authorized and what is not authorized. So thanks to the plugin from Apple, you have the zip file. Now you need to deploy that zip file to Lambda. So I wrote another plugin called the deployer plugin. And so if you look at the project right now, you have the Lambda packager. It's written by Apple. And then you have the Lambda deployer. It's not currently final in the project. It's still under review, under code review, but I hope it will land in the repository in a few weeks. So that plugin is quite simple to use as well. You type Swift package deploy. So one single line, and it will deploy your Lambda function to Lambda. But remember, when you deploy a Lambda function, you're not just deploying Lambda. You need an API gateway, an SQS queue, you need permission, policies, a database. You have more infrastructure than just your Lambda function. And I didn't want you, a developer, to learn the YAML from SAM or to learn another tool to write infrastructure as code. So what if you can describe your infrastructure as a Swift file, so that in Swift you can describe that you want a Lambda function, you want an API gateway in front of it, and you want a database behind it. So how do you do that in Swift? you add to your Lambda project a simple deploy.swift file. And that Swift file lets you describe, using the Swift programming language, the AWS infrastructure that you want alongside with your function. So it's a deployment descriptor using the Swift programming language. And look at the structure, it looks like Swift UI. You have building blocks, they can have a parameter, they can have modifier. You have the concept of a function, of environment variables, and others. So let's have a look at that in the detail. You start with deployment descriptor. Of course, you need to import a library to make that work that defines all these structs. So AWS Lambda deployment descriptor. Inside the deployment descriptor, you add a description of your deployment descriptor. You add one or several functions, and you give your function a name. Then you tell us how you want this function to be invoked. So you add an array of event source for each function. In this case, the event source is an HTTP API that will accept HTTP GET on the path /test. You might also add environment variable for your function. For example, the log level being debugged. So that's just a dictionary of a string. So that's all you need to do. You write the deployment descriptor in Swift, you invoke the package, and it will deploy, you invoke the plugin, sorry, and it will deploy the infrastructure on AWS for you. So how does it work behind the scene? Again, I'm using SAM. So the plugin detects and reads your deploy.swift deployment descriptor. It will dynamically compile that file and generate a YAML SAM deployment descriptor. The YAML file stays there on your project, so if you want to modify it, it will not be overwritten by the plugin, so you can enrich it unless you force the plugin to overwrite it. It will keep your change in the SAM deployment descriptor. The SAM deployment descriptor is exactly the same as the one I showed you before. And the second phase of execution of the plugin, after it generates the YAML deployment descriptor, it will call the SAM command line to actually deploy that and create the infrastructure for you, so the API gateway and Lambda. Can you test that locally? Yes, you can, because SAM has also a way to test your code locally in a mini Lambda runtime environment running on Docker. So you can type the command SAM local invoke. You pass as a parameter the template that has been generated, and you give the JSON of the input event that is going to send to your function. Then you give the name of your function. When you type that command, you receive tons of debug output. It's difficult to read, but look, my print from my code there, HTTP API message receive is there, so you can debug your function from there. So as I said, the deployment plugin right now, it's work in progress. It's currently under code review. The pull request has been made, but I have tons of ideas about what to add there. First, if you are interested by that, let me know how you would use it. What is missing? How can we make it better, easier for you to deploy your Lambda function? So I need your feedback. You need to tell us what to prioritize and what to do next. But I have tons of other ideas, like making it more SAM compatible. Right now, it implements a subset of what SAM can do, like functions, queue, HTTP API, part of HTTP API, environment variable, basically all the stuff I showed there. But SAM can do much more, so we probably need to add more Swift construct for SAM into that as well. I also would like to add user authentication by default on the REST API. Right now, the REST API are public, and that's really not a good security practice. I don't like to ship sample code or demo code which is not secure by default. So I'm thinking about making it a bit more opinionated so that it will enforce some kind of authentication with JWT or something like that on the API gateway. Add more samples for database. I know database, it's a big pain when you're using Lambda in general. So how can you add code that connects to a Postgres database or MySQL database, for example? How to add code that use the AWS SDK for Swift to interact with other AWS services, such as DynamoDB or S3. Wow, that was a long ride. So what did we talk about? I talked about AWS Lambda, how it scaled from 0 to million, how you pay only for the actual usage. If you are not using it, you are not paying for it. I told you that most of the time you want to deploy your code using some kind of infrastructure as code, so describe the infrastructure and have something to deploy the infrastructure for you. So I introduce you my friend Sam, and I show you how you can combine Docker and SAM to deploy on Lambda unmodified existing web application. I took the example of Vapor because we are talking about Swift, but it can work with TypeScript, with Python, any type of web application running inside a Lambda function. And then I show you how you can create a Lambda function in the Swift programming language and how you can use two plugins that are part of the AWS Lambda runtime open source project, the package archive and the package deploy with the help of a deployment descriptor written in the Swift programming language itself. Are you still there? So let me know what you are going to build. What are you building on the server side with Swift? What type of frameworks are you using? What type of deployment platform? Come to me. I'm staying here all day, all afternoon. Thank you for having watched this talk. If you don't want to talk to me in person, you can also reach out to me on LinkedIn and Twitter and Mastodon. You can find me super easily. And let me know specifically about this talk, because it's the very first time I'm delivering this talk outside of AWS. So you are the first person not working at AWS in the world seeing this talk. So let me know how it goes. I have to make it shorter, longer, improve some parts or others. And if you fill in that very, very, very short survey with 4 questions, it's totally anonymous, you can get a $25 voucher that you can redeem on your AWS account, and it will be deduced from your next AWS bill. Thank you.
That's a cool QR code. How does that work?
QR code monkey, Google QR code monkey. I'm not making them myself. It's a web app.
Well, thank you, Seb. That was great. Do we have some questions? Come on now. I know it's early. Someone must. Here we go.
I'm post-technical, but I was interested to see that the adapter for the Lambda function is actually polls, like your custom adapter. So Lambda is a sort of point-in-time event-based, but then you've got this thing polling on the back end. So what's doing the polling? Like, obviously, you're not paying for a server to sit there and poll.
No.
And how do you configure how frequently it polls?
If you write your own Bootstrap, the recommendation is to do long polls. So you poll, and actually the connection stays open. As long as the connection is open, the Bootstrap wait for the events to come. Of course, TCP connections are limited in time, so at some point it will be the connection will terminate. Then you make a next connection waiting. But you only pay when your handler is called. So you do not pay for the micro VM and the polling part.
So following on from that one there, so the micro VM, just to clarify, the micro VM stays alive 24/7. You don't pay for it. It's only when that micro VM runs your event or your function that you actually pay to use it.
Almost. For optimization reason, we might turn off your micro VM totally. So if there is no event coming, at some point we might shut down the micro VM to reuse hardware space. Yes, exactly, and that's something which is well documented, and there is tons of articles on internet about that. It's called the Lambda cold start. So when we don't have a micro VM, we need to start it up. So we developed our own micro VM system. It's called, I forgot the name, but we have our own open source technology for that. And yes, depending on the runtime, it might take some longer time or smaller time to get your first Lambda function invoked. With heavy runtime environments, such, I don't want to blame anyone, but Java, especially if you have Spring, there is a lot of dependencies to load initially. So compiled language usually are better at that. Go, Rust, Swift is quite efficient in terms of initial startup time.
Thank you.
Anyone else? No, well, thank you so much. Another big hand for Seb also.
Okay.